Now, going to the vertical speed indicator. Vertical speed indicator, one more type of the instrument which requires the only static pressure supply. It looks from the internal part pretty similar with a barometrical altimeter, but it has some amount of the difference. So we still have a source of the static pressure, which is going inside of the special capsule. Inside of the whole case, we will still have the static pressure, but we will have some difference. If inside of the capsule we have a static pressure, and inside of the case we will have a static pressure, our instrument will operate only in case if the static pressure is changing. How? The reason how this instrument actually works, it's work because of the volume of the capsule much smaller than the volume of the whole case. And pressure inside of the capsule will adaptate to the new condition much faster comparing to the pressure inside of the whole case. So technically, when, for example, we are descending, static pressure start to increase. So this pressure will really rapidly increase inside of the capsule and kind of slowly will increasing inside of the whole case, especially because we have a specially restricted hole into this pipe. And the faster actually changing the altitude, the faster changing the static pressure, and the more difference will be between the pressure inside of the capsule and outside of the capsule. So the more indications we will have. Also, for increasing, of course, this instrument is not working immediately, and we are using the vertical speed indicator for steady climb or steady descent. For steady climb or steady descent. And this instrument is not really reliable for immediate information. So we are really climbing or really descending at this moment of time, for example, because of the bumpy turbulence or gusting condition. The thing which can increase or like decreasing the time of the correct answer, it's the special accelerator pump which can be inside of the vertical speed indicator. Again, the principle of operation simply. For example, pressure, we start to descend, pressure start to increase. The pressure is start to going into the case, also into the capsule, and here we will have a piston on which on the one side will be acting the higher pressure. So this piston will going up and faster change the pressure inside of the capsule. If the pressure is changed faster, so our instrument become more sensitive and much quicker will answer on our request. In case the pressure is drops again, so the pressure will quicker decreasing in a capsule, and in case if we need to decrease the time of reaction, so we will have the accelerator pump, but in our case this piston will go in opposite direction and quicker decrease the pressure inside of the capsule. What we need to know about the vertical speed indicator? First of all, error, instrument error, position error, maneuvering error. Pretty similar, complex like with our barometrical altimeter. What will happen in case if this instrument is blocked? In case if this instrument will block because of the icing, ash, dust, dirt, whatever, this indicator will indicate just a 0 for us all the time. Because for this instrument, if the pressure, static pressure is remaining constant, so pressure inside of the case and inside of the capsule will be the same. If they are all the time the same, we don't have a difference in static pressure. It will all the time indicate the 0 for us. So altimeter indicate for us altitude at which blockage happened. Vertical speed indicator will indicate 0 because static pressure not changing anymore. Also, in case we will activate the source of the static pressure on board of the inside of the cockpit of non-pressurized airplane, static pressure inside of the airplane again lower. What will happen with our vertical speed indicator? It will rapidly shows the climb because static pressure decrease. So that will be equivalent like we are climbing. So it will initially represents the climb, and then if we will maintaining the constant altitude, it will going back to the 0 because initially pressure is changed, then it will remaining constant, and the instrument will working absolutely normal, like with a normally operated static port.